Now we'll talk a little bit about paint circulation system, which I've spoken before as well. So the Patvin's Smart PCS, which is our flagship product, which will maintain uniform viscosity, then it will maintain uniform velocity, it will meet pressure and flow requirements for both manual as well as robot applications. It will maintain particle velocity so that you don't have any kind of settling in the paint lines, so that you don't have any kind of dirt accumulation, and you'll have uniform shade or no shade variation. It will also maintain suspension of paint in tank to avoid settling and dirt formation, real-time pressure monitoring, then smart barcode scanning, and the smart notification system. In a gist, this is what it is: smart temperature control, smart viscosity control, smart velocity control, smart agitation, smart pressure, smart notification management. So typically these are the factors contributing to paint quality. The paint variables, the density, viscosity, temperature, paint type, and solid or non-volatile materials present. So these factors of the paint variable are controlled through our smart variable system in the most efficient manner. So we are also not only helping save energy, but also ensuring that there's less rework through the paint variables. This is how the smart temperature control system looks like. It is both hot water and cold water on a real-time basis. So the viscosity control is used with a closed loop. Again, this is how it is. The PCS tank is there. Then you have a paint doser, you have a solvent doser, an inline viscosity meter, and we are measuring the inline viscosity, and we are online dosing the same. So dosing with solvent to adjust the viscosity. So this is already implemented for clear coat in Mahindra. So this is how it is. So with this system, the tolerance band is very, very close with the viscosity, and thereby defects like rundown, etc. can be managed much better. This is about the smart color demand. So this is a further energy saving, wherein the colors that are in production or the vehicles that are in the booth, which will be painted, only those systems will be in the high pressure mode, whereas all others will run in the low pressure mode. So this possibility is, this thing is only possible with electric pumps and not with the traditional pneumatic pumps. So with the electric pumps, you can do all the programming through the PLC control panel, and you can have the colors that are going to be used in production at a higher pressure and the others at the lower pressure. So the current drawn is further less on the motor, and you save a lot more energy and thereby costs. So this is how it is. You can see the colors moving in. If now the colors in the booth are 813, and those are the only pumps which are in the high pressure mode. So as we move through, so this is about the velocity control. So the velocity is typically maintained in two ways, where we maintain the pump cycles and we are monitoring it real time and correcting it in a closed loop. Or we can also have an online velocity meter, but that becomes a very, very expensive proposition to put in all lines. So the best way or the easiest way is to monitor the pump cycles and make a closed loop solution to maintain the same. Any deviation, an alarm will generate, as well as it can be corrected in the same cycle. Again, on the smart agitation, we have a level monitoring system tied up with the agitator. So we can program the agitator as in a way that as the level is going down, the agitator speed can go down, so that there is no splashing, as well as there is some energy saving. Plus, with the electric agitator, we can also put a timer and put it off for a while, and it does not affect the paint quality. You can do on off, and you further save some energy on this. This is how it looks like. So when the level is going down, you reduce the speed. Then we have the smart barcode scanner. This again is already installed in a couple of locations, where to avoid wrong loading of color. So there's a barcode that comes on the paint barrel, and our system will, with the barcode reader, will tell the operator with a green and red signal that, okay, this is the right barrel to load or the right batch to load. And then we have the smart notification management, and where we can give the major alarms and warnings to the respective stakeholders, whether the line supervisor or the robot control panel, etc., or to the guys manning the booth, to know whether there are any faults, or whether the paint is less, or any kind of major alarms that can be predefined and also can be sent to predefined cell phones. So we talk about a lot of sustainable solutions and digitalization in the paint circulation. So that's our forte, and we have delivered more than 50 such systems in India and across the globe right now. So what the benefits? Higher productivity, reduced operational cost, quality and consistency, less human error, real-time data, and reduction in downtime, and reduced resources required for operating. These are just some examples of how the system looks in a SCADA or in a supervisor's cabin, where he has the overview of the entire system functioning, which robots is painting, which how the agitator is moving, what is the speed of the agitator, what is the energy consumption per hour, per day, so which can be monitored, can be given to your in-plant management system to maintain the data or to figure out more further better ways to reduce the energy. So these are the kind of mode selection, and then this will show exactly which pump you want to put on, off, put a timer. All of this is configurable as per the needs of the production and as per the needs of the paint shop. These are some other process monitoring screens where you have more data on details on individual tanks or individual systems. Most important is we are able to make sure that we demonstrate, not only talk, but we have demonstrated as well as proven in the field with our installations the energy consumption. You can see exactly how much energy is consumed real-time basis. You can see in the power that is changing with the agitator speed, and side-by-side comparison with a pneumatic agitator, a pneumatic pump has been done, and in the field we have got almost up to 50% energy saving. Our customers have got, some customers have also completely removed the dedicated compressor they had for the paint mix room with this kind of systems, and that has contributed to a lot of savings to them. So it's not only cost savings, but it is also savings on energy, and thereby helping the customers to meet their corporate sustainability goals and working towards a carbon neutral future. So similar setup on many projects. These are all real project screens and data, not just made for the presentation. I've just pulled out recent data from the last couple of weeks from a couple of customers that we have installed. This is how it is, the weekly calendar for the energy consumption, and it can be monitored by the paint shop managers. So our system is a highly data-rich system which helps customers make a lot of analytical decisions and help them plan the production also in advance based on their ERP or their SAP or their daily production plan. We can pre-program our system and make sure that the system